Welcome back. This is the second lesson recording for IM2, May 17th, 2021. Now we're going to talk about surface area and volume. So what's a surface area and what's a volume? Well, surface area, if you can think of this apple juice box, surface area is the amount of paper needed to cover the solid, while the volume is amount of material a solid can hold. So in this case, how much juice I can fit in this box will be the volume. Okay, if I was to talk about what is the area of the paper to create this box, juice box, that would be the surface area. Like again, the amount that you can fill in is the volume, while as the paper it takes to create this box will be the surface area. And for now, we're going to be working on surface area. So to find the surface area of polyhedron, a polyhedron surface areas are too diverse, so there is no one-size-fits-all formula. So you need to visualize and decompose into faces, and 2D nets help us visualize the faces. And to do that, we are going to be looking at 4 different problems, and you're going to be doing this on your own, or you can work in your groups. You're going to be given 25 minutes, and there is a document that you are going to be opening. And if you have a printer, you can print it out and work on the paper. If you have a tablet, it's a Google Doc, so you can work on the tablet itself, and you can use your annotation tool. If you do not have either, which is not a problem, you are going to be working in your notebook, and you are going to be submitting it, whichever form you're doing it, at the end of the class. And if you need any help, you need to be asking. And there are 4 different GeoGebra links that is there. So if you look at that, if you open the 3D solids and the 2D nets, it will look like this. Okay, so this is the document. Okay, let me go to the top. Here we go. All right, so there are 4 problems, and you can see there are links here that you can click on: rectangular pyramid and sided pyramid. Okay, so we're starting with pyramids here, and this will give you the link to the rectangular pyramid, and it shows you a net, so you can fiddle around with it and to see. This is what happens when you open it up. Okay, so that's the solid stage. What if I was just create a net by pulling apart each of the surfaces? What would the outside surface look like if you just created a flat paper? Okay, so it would be a rectangle in the middle with the triangles on all 4 sides. They're going to have different dimensions. Okay, so this length, the base of the left triangle is going to be this length of the rectangle. The base of this 2 triangle, this bottom one and the top one, is going to be the length of the rectangle here. Okay, and this height is going to be different to this side of the triangle, but this length and this length will be the same though. Okay, so you need to try to visualize the net. Net is just a 2-dimensional representation of just the different surfaces of the 3-dimensional shape. And this is a net for if you have multiple sides on the base. Okay, so if n is 9, or it could be triangular, like so, triangular. Okay, and you can create nets like that. Or it can have the base could have 4 as a side, and it can have many different how you can modify that. Okay, So play around with them. Then you are going to fill in the information. Sketch its net. Label the known measures. Surface area calculation, the area of the base, that area of the different size faces. Then you're going to end up with your final surface area. And I've given you the answer, okay? The final answer you should get for you to be able to check if you're doing it correctly. And there, here's a triangular prism, then you do the same. And again, there is a GeoGebra link. Don't forget to click on that and play around with it so that you are familiar with the nets. Rectangular prism, then finally rectangular. Oh, this is not a rectangular prism, but this will be this is a pentagonal pyramid, okay? And you would use the n-sided pyramid to link that. Okay, I'm going to assume you better go. And here are the answers being revealed. Okay, so this is the first problem where you had the pyramid. It was a rectangular pyramid because why? The base shape is rectangle and it has the width of 8 miles and the length of 9 miles. And we are given the slant height. Okay, slant height. Okay, so you can see that this length is going to be different to this length. Why is that? Because the distance from this point to the apex is going to be different from this side to the apex. Okay, and so how many triangles? So is the base regular? No, it's not regular because the sides are different. So it's a rectangle. How many triangle faces? Well, the base has 4 sides. That means we're also going to have 4 different triangles. Okay, but two opposite sides are going to be the same. Okay, so this side here and the one on the back is going to be the same base, same triangle. This one on the left and the one on the right, they're going to be identical triangles. Is there enough information to find all the areas? Okay, well, let's see. The first thing you want to do is try to visualize the net. If I open that, it should look like this. It will be a rectangle at the base, and you would have 2 triangles that look identical and 2 triangles that look identical. So we have 4 triangles. What else do we know? Okay, so surface area is the base area, so we can figure out the area of the base, and then 2 skinny triangles, the area of the 2 skinny triangles and the area of the 2 wider triangles. Okay, and the base area is, we know that this is going to be 9 by 8, so it's going to be 9 times 8 plus 2 times, why do I multiply by 2? Because area of the skinny triangle, we have area of the skinny triangle. This will be the skinny triangle, and we have 2 of those. And how do I calculate the area of this triangle? It's going to be base times height times half. What is the base? This base is just the same as the width of the rectangle, right? Rectangular base, which is 8. That's 8. What about the height of this triangle here? Well, we're told that this height is 10.1. So this height is 10.1. So it's 8 times 10.1 times half. But then we have 2 of those. So 2 and half, they cancel out. So it's just 8 times 10.1. What about the 2 wide triangles? It's this one and this one. And again, there are 2 of them. Area of one of these triangle is half times base. Base is going to be the length of this triangle, which is 9, times height of this triangle, which we're told is 9.8. So it's 9 times 9.8 multiplied by half, that's area of the triangle. And since there are two of them, we multiply by 2. So that becomes 241 miles squared. So that is going to be the total surface area. Second problem. Okay, so where are the bases? When you look at this, where are the bases? How many faces? How many faces are the same size? Is there enough information to find the area? Okay, so first thing you want to do is you want to be able to visualize this by creating a net. Can you kind of open it up? The bottom will be this rectangle. And then there is this rectangle here. That's this blue rectangle. And the one right at the front is the green rectangle. Okay, and then we have two identical triangles. That's the brownish triangles on both sides, right? So we have the triangles at the base. This is a triangle and this is another triangle. They are triangles. How many faces are? Okay, we have 1, 2, 3 faces plus the 2 bases. Okay, so we have 3 face rectangles of different size. Is there enough information to find all the areas? Well, we know that this length is 8 inches. And we know that this is 6 inches. We know that this is 4 inches. And this length is same as this length, okay, because it's a rectangle. This length 6 inches and 6 inches are the same. Okay, so we know that it's a right angle triangle here. So that means we can also figure out this length by using the Pythagorean theorem. So the surface area is 2 base triangles plus all the back panel. This will be the back panel is the purple triangle or purple rectangle plus the front panel. Front panel will be the green rectangle, and the bottom will be the yellow rectangle. Okay, and do we have enough information? We need this length. We are not given this length, but we can figure it out using Pythagorean theorem because we know this length is 8 inches and this length is 6 inches. And so we can figure out this hypotenuse of this triangle. So hypotenuse squared is going to be 8 squared plus 6 squared. So hypotenuse is 10. We know this length is 10. Do we know this length? This is going to be same as 4 inches, 4 inches. So it's going to be 10 times 4. So that's 10 times 4 is the front panel. The purple panel is going to be, this length is going to be 4. This length is going to be 8. So 4 times 8. And the bottom panel is going to be, this length is 6. This length is 4. So it's 4 times 6. And then we have 2 of the brown triangles. 2 times half times the base of this triangle is 6 and the height is 8. So 2 times half times 8 times 6 are the 2 of these brown triangles, and that is 144 inches squared. Okay, number 3, we have a rectangular prism. Prisms must have the 2 bases of the same size and rectangle faces. So where are the bases? How many faces? How many faces are the same size? Is there enough information to find all the areas? Well, again, I want to visualize the net. Okay, you can pull it apart. Visualize it from there. We have one base here and another base here. If I consider those two to be my base and the face on the back, 2 sides, and the face at the front. Okay, so this is my pull apart of that. So we have 2 opposite sides and you can pick the 2 and 5. I can pick 2 and 5 as my base. I could have picked 2 by 4. I could have picked this side and this side. It does not matter. it will all work out to be the same. How many faces